Namaskar. Welcome to Prakash on Basics. I am Prakash Zog. We are going to talk of one of the most important organs of our body, the heart. It's a very vital organ. It's not a seat of emotions and feelings as it is depicted in so many poems and poetries and songs and so forth. It's among the most hardworking organs of our body. Basically, it's a non-stop pump. It starts before our birth. The heart starts beating around the fourth week of the fetus, and when it stops, usually that's the end of life. It beats around 72 times per minute. It pumps 5 liters of blood per minute around our body, non-stop. And for this, it has a group of muscles which are not directly under our control. I'm at of my age now is 70 years. So in this all this time span, my heart beats have been roughly close to 2.5 billion beats. And the amount of blood that has been pumped around could be around 183 billion liters. That's 183 big drums of 1,000 liters each. A little less, probably more in some cases, because that would again depend upon the heart rate itself. The basic function of the heart is to transport blood to the variety of parts within our body. Dominantly, of course, to the brain. 25% of it goes to the brain. Um, and in the process, it has many other logical functions because then it is carrying nutrients, glucose, oxygen, hormones to variety of parts of the body. It's also bringing back waste, carbon dioxide, water vapor, some of the nitrogenous gases, etc. These are the direct effects of the transport of the blood itself. But then it also maintains the pH of the blood. It maintains temperature at variety of parts within our body, because if the blood flow is less, you start feeling at the cold at the appendages. It also ensures that the pressure, osmotic pressure at various parts of the body itself is maintained to its optimum level. This heart is the greatest workhorse of our body. How big is it? It's just about 250 to 350 grams, one third of a kilogram, or a little one fourth of a kilogram. It's hollow. It has four chambers inside, and it is slightly to the left of our median, and it is placed within what is known as the thoracic cavity. It's as good as, you can't say exactly like one fist, but a little more than that is the size. Because of its shape, it's around that size. And it is placed within a sac, which is known as the pericardium. Peri is surrounding. So, surrounding bag. And this bag itself is in the thoracic cavity and is attached to the various sides. And the heart then remains suspended, slightly inclined, as you can see in this figure, slightly inclined, but it's not completely to the left. It's not like in so many films where a bullet is fired here and the heart is punctured. It's more towards the center. And it's suspended so that it is free of shocks and vibrations. It's made up of involuntary muscles. So we don't have a conscious control on these muscles. You can't say, I'm sad, I'm depressed, I'll will my heart to stop. You can't do that. You can't will it to work faster. So it's not in our control. But it has to work very efficiently. So remember when I talked of the cells, there are mitochondria. These are the ones that supply energy to the body, to every cell, in fact. So the percentage of mitochondria in it is roughly around 25% more than all the other body parts and all other situations, because it needs a lot of energy, and it cannot undergo fatigue. You cannot say, I'm tired, my heart will stress and stop for some time. That is not going to happen. In fact, it is quite likely that when you're tired, your heart will start working a little more than normal. It's a highly evolved organ. Started out with two chambers, and then you had three chambers, and now we humans have four chambers. And it's basically a electromechanical pump, because it is electricity, our base topic at present, which actually sends out the impulses that control the variety of muscles that are there, resulting into that pumping action that we know of. It needs energy, and that energy is supplied by coronary arteries. They supply the blood to the heart itself. And when people talk of blockages, etc., in for hearts, that heart individually, then that blockage is usually in these coronary arteries. Either the cavity becomes a little too small, or tends to bend and so forth. So what you do is you put a stent inside, and that's nothing but a collapsible spring that is put inside, which opens out and ensures that the cavity and the gap remains for the blood to flow through. And that blood supplies all the necessary oxygen and glucose for all these muscles to work. The whole system is actually hollow. It consists of four chambers, uh, as you can see in this, one, two, three, and four of them. They two above and two below, left and right, obviously. The diagram usually is the way in which you face a person. So naturally, this side then is the right, and the left on the other side. The cavities or the chambers on top are known as atria or atrium, each one of them. Uh, and the lower ones, the bigger ones, are known as the ventricles. So you have the right atrium, right ventricle, left ventricle, and they are all connected uh, to each pair with a set of valves. There are two major valves that you can notice at this point, and there is one between uh, the right atrium to the right ventricle, and this has three flaps, and they are known as it's typically known as the tricuspid. Cusp is a shape like this, so it's a tricuspid. It's like me having three arms, so it's a tricuspid valve which opens only into the ventricle, that is the lower chamber, and it is connected with a set of springs. It's typically known as a valve because it's going to allow blood to flow only in one direction. So it opens like this, and when it tries to go back, the muscles attached to it ensure that it doesn't really go back again. And then between the other side, which is between the left auricle and the left ventricle, there is another valve, but it has only two flaps, and it is known as a bicuspid valve. It has another name because some of you all who must have read about heart and heart problems know that this is known as the mitral valve. So that's another valve. So you have one, two, three, four chambers. They're not of equal size and they're not of equal strength and so forth. That I'll go up to a little later sometime. And you need to get blood inside. And so all the blood from the body that has been used to be processed through the heart comes through two major areas: the part above our heart and the part below our heart, and they all land up on the right side. So there's one pipe that comes down like this and one coming up, and they collectively enter this area. And this upper part, vein, is known as the superior vena cava, or cava as you pronounce it. And the lower one is the inferior. It's not inferior in any sense, but lower. So inferior vena cava. They merge into each other, and all that blood comes into the right auricle or atrium. Previously, the word auricle used to be used, and then it starts flowing downwards. It goes through the wall into the lower part, and then the blood has to go to the body, and that is supplied again from this part, which is the left ventricle. It goes into one of the biggest arteries, and that goes into our body, which is known as the aorta. Please realize that arteries and veins are the two tubes that are associated. Veins are the ones that terminate or move the blood towards the heart, and arteries are the ones that take blood away from the heart to the various organs of the body. And if you remember your schoolwork, it's typically they are said to be red for the arteries and blue for the veins. Actually, if you look at the arteries and veins on your body, you would see that they have a bluish tinge, but the blood inside is not blue. The blood is always red. It's only that it is dark red when it comes, or when it is without oxygen or deoxygenated, or the one that has been used up. And when oxygen is put into it, which is known as reoxygenation of the blood, now that makes it bright red. So what goes out is the bright red blood, and what comes in is the darkish red blood. So these are the four chambers. The shape, it's not like the typical heart shape that we have on visiting cards and so many other places. And surprisingly, it is this lower part that is known as the apex of the heart. Let's try and get a basic idea how it works. That's more important. So the body uses all the energy that is available, and all that energy causes oxygen to be consumed up, and the blood, it also collects all the waste matter from all that area and brings it back, and through the superior and the inferior vena cava, the blood comes down to the left atrium. It has some pressure of its own, so as soon as it comes in, the valve that is there, the tricuspid valve, opens out, and all that blood starts flowing down, and it starts filling up the lower cavity, which is the right ventricle. When it gets filled up, which happens in a compression on the upper part, and it gets filled up below, it starts compressing the lower part also. And when that happens, the valve will not let the blood go back again. So it starts going out through this other opening that you see, the red one. And that is the one that takes the blood from there to the lungs. I talked of the lungs, remember? They are like broccoli or cauliflower, and there are very small bundles inside where the blood reaches, and in the lungs, and it exchanges the oxygen carbon dioxide process takes place because of osmosis, and the blood becomes regenerated in terms of oxygen. So it fills up all the hemoglobin atoms, molecules rather, with oxygen, and that blood comes back. So this oxygenated blood returns from the lungs and comes back. The arteries and veins, the lung part is associated with the word known as pulmonary. So this is the pulmonary artery that takes the blood to the lungs, and it is the pulmonary veins that brings the blood back again, actually from each of the lungs, and there are two of them, and they all enter Four of them total enter into the left auricle or the left atrium. Now, once it begins to fill up this part, that pressure itself causes majority of the blood to start trickling into this big chamber, which is the left ventricle. And then there is again a little bit of compression and all the blood goes inside, and then this begins to compress. And when it compresses, it pushes all the blood back again. And this, then the valve closes down. The mitral valve or the bicuspid valve closes down and it starts flowing through the aorta. Realize that even aorta and this pulmonary artery must have their own valves, but they are known as semilunar valves because they look like a moon disk, and they are controlled by muscles. And so through these semilunar valves, the aortic valve, all the blood starts flowing to the different parts of the body. And that's how blood flow takes place in our body, circulatory system as it is known. But the major part is the pump that's working here. So it's taking in blood, pumping it to the lungs, it gets purified, comes back, and then it is pumped and circulated throughout our body. So that's the sequence that takes place. But we don't hear four beats. They're all synchronized. It's a highly synchronized process. In the process, the blood also flows through our kidneys where it is filtered out and all the waste products and urea and other stuff is removed, and that circulates. In the process, it travels all the way around in our body, a major chunk going, of course, to our brain. So the vena cava brings in all the used up blood, and the aorta takes away all the fresh blood to the various parts of the body. And that's how the whole system works. There are a few things that we must realize. This is an electromechanical pump, as I said, and it is associated with pressure. If somebody says, do you have blood pressure? And then people say, no, 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 I don't have blood pressure. Actually, if you don't have blood pressure, you are dead. Because without that pressure, you're not going to work. Your heart is not going to work. So when I say you have blood pressure, it means do you have pressure more than necessary or lower than necessary? And that pressure is the one that we must know of. Hypertension, as it is talked of, that is higher blood pressure than normal. So it's this part is then associated with the physics aspect. And it talks of is what happens because of pressure. So liquids will always flow from high pressure towards low pressure. So if the heart pumps, it's going to send blood with pressure out. Think of what you see when there is a cycle pump, or typically a car also when they bring in a pipe from the compressor and put it inside the tire and start pumping in air. It is this tube that builds up all that pressure, and it is the pressure in this tube that is measured. In our case, in the arteries and veins and so forth. And so when the heart is compressing, the pressure is built up and becomes higher, and at that time you measure the pressure within the arteries, and that is the one that is talked of as systole. That is when the heart is compressing, and that is ideally expected to be 120 millimeters of mercury. I'm coming to what it is. And then after the compression, the heart relaxes. When it relaxes, the pressure drops, and it drops down to approximately 80 millimeters of mercury pressure. And so 120 and 80 is this range of pressure that exists within a variety of arteries that take away blood and return, of course, via the veins. How do you measure it? So I'm sure many of you all have gone through the process. They put a strap around and start pumping in air. What has that got to do? It's a very logical and a nice area. So what they are trying to do is they cannot puncture inside and measure the pressure inside. So it's like people pushing a door from one side. So if there are X number of people pushing from one side of the door, what you do is start increasing the number of people pushing from this side. When the number becomes 4 and the door remains balanced, it means that other side there must be people equivalent to 4. That's the logic. So it's pretty simple. So what you do is you start pumping, and when you do that, it starts getting compressed. And so the blood flow starts reducing. And at one particular point, the pressure from outside balances the pressure within the artery. And then that point, the pressure indicates that this is balancing the pressure inside, which is supposed to be 120 millimeters of mercury. How do you detect this? So what the doctor usually does is he has a stethoscope and he is simultaneously checking the pulse. And as the pressure starts increasing here, the blood flow starts reducing. And at one point, it stops. So the beats that he is measuring at this point stop. And then he knows that it has reached the necessary pressure to balance, and that is expected to be 120 millimeters of mercury. And so through his stethoscope, he starts reducing the pressure again till he starts hearing the beats once more. And the instant he starts hearing beats once more, he says, oh, now the pressure has reached 80 millimeters of mercury equivalent. And then that is the lower part, which is known as the diastole. So systole and diastole represent the values of the blood pressure that is there for ideal situations. As to what that 120 millimeters is I talk of when we talk of barometers and how pressure is measured. But atmospheric pressure is 760 millimeters. Realize this. So 760 millimeters, and this is only about 120 millimeters, the pump that is working within our body. I'll talk of that when we come to pressure and atmosphere and other stuff. So that's how it works. So that's how pressure, the regular thermometer, blood pressure instrument works. Now, of course, we have the electronic ones that are slightly different. So what happens when your blood pressure goes higher than necessary? It results into hypertension, and when it goes below the 80 mark, it is said to be low blood pressure. And there could be so many factors. Sometimes you need more blood. So if there is too much of excitement, then naturally the value will go up and the blood pressure would tend to rise. The heart number of heartbeats will also tend to rise, and vice versa. Now, there are one or two more things that we must know. This heart has walls, and walls are made out of. So when they hit each other, they are bound to produce some sound. So when they open and close, the ones that are there on top and the ones below, each one has its own set of pressure values, and does impact creates some noise. The doctors usually refer to it as lub and dub. So lub dub dub dub. This is the type of rhythm that's maintained within the heart. So when the stethoscope is put, or even if you put your ear to the heart of a small child, you will start hearing that noise, which is referred to in medical terms as lambda. And every one of them is said to be one cycle of the heart. And that's how things work. If it doesn't really synchronize properly, there could be a whole lot of problems that go around. When arteries thicken out or there are deposits inside, pressures begin to build up. When you don't, aging causes all these problems. Heredity could also cause such problems. Overweight, when you eat too much and the body cannot store the fat, it starts storing it in the arteries and the cross section. If it is this much, there is deposit inside and it starts closing down. And so the amount available for the blood flow starts becoming less, and there is a problem. So all this results into a pressure that is put on the heart, which results into higher blood pressure, cholesterol, smoking, drugs. These could also cause all these problems. So we have a heart, which is a pump controlled by electricity, controlled by our muscles, which are not directly in our control, and they function. And the blood is pumped around. That's what I have told you. This is something that all of us must know how the heart works. But the things are not really that simple. If all of them compress together, it will explode. There are a lot of other problems. So there's a lot of synchronization. And that is the beauty of the heart. How does that happen? I'm going to come to that because I want you to think of all this. Keep this picture clear in your mind, and then we will see how nature, according to me, looking at the amount of development that has taken place even in the heart or in the brain, that itself is God. Nature is God. How could it have evolved just in about 3.5, 4 billion years to this extent? That beauty of the working of the heart is something that I will talk of next time. It's a little higher, but it's very interesting, and it's essential that we know what it is. If you have liked whatever I have said, put your hand on your heart and feel that great pump that started when you did not understand things, where you were just a 4 week fetus, and it will beat on, beat on, beat on till last day. That's our heart. But the beauty of how it works is something that I will talk of next time. If you liked whatever I have said, please like and subscribe to this channel. Tell this information to your friends also. Understand the beauty of how our body works. Till we meet next time. Namaskar.